Hey guys, welcome back. So today is day 2 of compound inequalities. Let's go ahead and write down today's objective. I can write and graph compound inequalities from word problems. Now, we did this yesterday, but just to give you guys a reminder about what a compound inequality is. A compound inequality consists of two inequalities that are connected by an and or an or. Now, just to remind you about and or, we did talk about it yesterday. And is when you have a solution to both categories, to both inequalities, okay? And when you are trying to find out where the solution is, it's where you see overlap, so overlapping shading. Now, an or is when you have a solution to at least one of the categories. So what you're going to do is find at least one shading, and then anything where there's at least one shading is a solution. All right, now if you need to press pause to write all this down, go for it. Otherwise, I'm going to go to the next slide. All right, guys, here we go. So we have x is less than 4 and x is greater or equal to 0. So we're going to put the 0 first because it's smaller. Notice that we have an or equal to bar here, so we do have to make this a closed circle. And then we have no or equal to bar over here, so we're going to have to make this an open circle. Now a number that would fit in here would be negative 100. Negative 100 is smaller than 4, and negative 100 would be up and to the left of this. Over here we can put 100 in there. 100 is bigger than 0, and 100 is up and to the right. Now again, and means overlap. So the only place you see overlap is in the middle over here. So we're going to shade this middle part. Right? Now over here we have an open circle, so there is no overlap there, because 4 is not a solution. Over here, there's green, and then 0 is a solution, so there's overlap right there because we got 0 and we got the green, so there's a closed red circle right there. Now, couple of solutions that would work are the ones that are in the middle of this, okay, including 0 because 0 is a closed circle, so we got 0, 1, 2, 3, and any numbers between those as well. Right, but 4 wouldn't work because it's an open circle. All right, go ahead and do number 2 on your own, and just recall number 2 has an or, so or means we have to look for at least one shading to be a solution. Go ahead and do that right now. All right, guys, hopefully you got this one right as well. So over here we have x is less than or equal to negative 4, or x is greater than 7. We know that negative 4 is smaller than 7, so we're going to put that one first. There is an or equal to bar here, so that's an open circle. There is no or equal to bar, so that's a, that's a closed circle, and this one's the open circle. Now the arrow that would be coming out of this one would be going to the left because negative 100 is less than negative 4, and that goes that way. Over here, 100 is bigger than 7, and 100 would go that way. Now this is, again, at least one shading. At least one shading means anywhere you drew a line would work. So we have shading over here. We also have shading over here because we have at least one type of shading. In the middle, there's nothing because there's no shading at all. Now, the other place that you would see shading is right here at negative 4 because negative 4 has a closed circle. Since this is an open circle, we are not including that one. All right, so some solutions for this one. We have negative 100, negative 5, negative 4. Now, negative 4 is included because it is a closed circle, but now 7 is not, so we'd skip 7. So we got 8, 15, 100. So these are some solutions for you. All right, let's do another one. For number 3, press pause if you need to correct anything. All right, guys, so here's number 3. We have x is less than or equal to 10 and x is greater or equal to 10. Go ahead and do this one on your own, and then we'll go over it. All right, guys, so hopefully you got this right. Now, again, we have x is less than or equal to 10 and greater or equal to 10. We're going to put the 10 on there, okay? Now, in both of these, we have or equal to bars. You can see we have an or equal to bar here. We have one right here. So there's going to be two closed circles, a blue one and a green one. Now, for the blue one over here, we have x is greater than 10. So a number that would work in here would be like 100. 100 is greater than 10. So that takes us up and to the right. For the green one, we have x is less than or equal to 10. Less than would be like negative 100. That would be up and to the left. Now again, and means overlap. There's only one place of overlap, that is right here where we have the green and blue circle. All right, there's only one over here, there's only one over there, so nothing on those sides. So there's only one solution to this, so that one solution is 10. Okay, now we're going to go to the next slide, and the next slide is review. This right here, let me go ahead and put it on there right now, number 4. So this right here is a refresher on inequalities. We did this before in the last unit. It says you have to be less than 48 inches to go on the kiddie ride at Six Flags. Okay, so a kiddie ride means that you have to be shorter than 48. So numbers that would work for that would be like 40 or 36. So the number that would go here would have, or sorry, the inequality that would have to go here, since 40 is over here, 40 is less than 48. So this is the inequality that we're talking about. Now to graph it, we're going to put the 48 there. This is going to be an open circle because there is no or equal to bar, right? And then the number that worked, we said, was 40 or 36 or negative 100. Negative 100 is smaller than 48. Negative 100 is that way, okay? Now that's just a refresher that we worked on together. You have another 2 that I want you guys to do on your own. All right, so let me go ahead to the next slide. So number 5 and number 6, go ahead and read them and then come up with the come up with the inequality and graph it. Go ahead and do that right now. All right, guys, so for number 5 and number 6, what we have here is we have inequalities. For number 5, it says you have to be at least 42 inches to go on the Superman ride at Six Flags. Okay, so we know we're comparing x to 42. Now, since it says you have to be at least 42, that means you have to be more than that. Meaning, if you were 53 inches, you'd be good. If you were 64 inches, you'd be good. So the inequality that I would put here that would work, so 64 is greater than or equal to 42. Now, the reason it's or equal to, because it's okay if you're 42 inches and you can go on the ride. So that's going to be a closed circle. And then number that would work in here would be like 100. 100 is bigger than 48. 100 is this way, so I'm going to shade this way. Now for number 6, it says you have to be at most 76 inches to go on the Superman ride at Six Flags. Now the reason you have to be at most 76 inches because there are dangerous areas for people who are too tall. They could hit their legs on like a pole or something when it gets to certain parts of the ride. So what that means is that we need to make sure that you are not taller than 76. So someone who's not taller than 76 would be like someone who's 50, someone who's 44 inches. Those are people who are not taller than 46. So that would be 50 is less than or equal to 46. Okay, so 76, I'm sorry. So there's the 76. So a number that would work in here would be like negative 100. So negative 100 is on this side. So that's the way we would shade it. Now, notice that number 5 and number 6 are both Superman rides. Now, what we're about to do is we're going to create a compound inequality. So we're going to do this one together. Now, I'm going to go ahead and read this for you. It says, to go on the Superman ride at Six Flags, you have to be at least 42 inches tall and no more than 76 inches tall for the rider's safety. Write a compound inequality to represent the situation and graph it. So here we go on the Superman ride. Now, again, this has 2 different inequalities in there, and you notice that these are the same inequalities as number 5 and number 6. So the first part right here where it says you have to be at least 42 inches, that's from number 5. So that's the x is greater than or equal to the 42. And then the second part right here where it says that you can be no more than 76, that one was from number 6, and we got x is less than or equal to 76. Now, we have an and that are connecting these 2 inequalities together. So we're going to put an and then you can see now we have a compound inequality. By putting number 5 and 6 together, we now have a compound inequality. So just like we did before, we're going to put these both points on the line. We have the 42 there. We have the 76. All right, now we do have or equal to bars, so we are going to put closed circles on both of them. All right, just like in number 5, we went up and to the left. Up and to the right All right, and just like number 6, we went up and to the left. Okay, so this is an and problem. That means that we have overlap. All right, the only place we have overlap is in the middle. So you can see that I shaded in the middle over here. Now the fact that we have 2 closed circles means that we also have overlap right here, because you have blue and then green. So that's going to be included. Over here we have green and blue, so that's going to be included as well. So this middle region is going to be what we have for our solutions. So our solutions would start at 42 because we are including it. Any numbers that are in between it, so we have these examples right here, 46, 57, 60, and 70. And then also 76 itself, because it is a closed circle. Now for number 8, you're going to try this one on your own. So here it is. Alright guys, so here's number 8. It says, in order to play in the high school basketball tournament, you must be between the ages of 14 and 18. Alright, that means that you have to be 14 and older, and you have to be 18 and younger to be eligible to play. Write an inequality that represents a person who is eligible to play in the tournament. Go ahead and do that right now. Alright guys, so hopefully you got this right. Let's go ahead and do this one together. So the first part where it says you have to be, right here it says you have to be 14 and older. So that would be represented by this inequality, x is greater or equal to 14. The second part is you have to be either 18 and younger. So that would be represented with this one, x is less than or equal to 18. There is an and between them, so we have to put the and side, and we just went ahead and created our and compound inequality. Now to graph it, we're going to put the 14 and the 18. All right, now we do have or equal to bars, so we do have to put closed circles. Again, the reason is because someone who is 18 and someone who is 14 can go and play in the tournament. All right, now the arrows for the blue one for the 14 are going to go up and to the right. The arrow for the green one is going to go up and to the left. And again, and means overlap. So the overlap would be in the middle again. All right, and we would still include the number 14 because there's blue and green. So you can see there's a blue dot and there's green above there. Over here we have a green dot and blue line up there, so they are included. We would include them in the shading, all right, and we would also include them in our list of solutions. We have 14, 15, 16, 17, and 18. Those are the ages of someone who can play in the tournament. All right, so number 9 is very similar to number 8, but this one's not asking who is eligible. This is asking who is not eligible. So for number 9, these are people who are not eligible because it says in order to play in the high school basketball tournament, you have to be between the ages of 14 and 18. That means if you are under the age of 14 or older than 18, you are not eligible to play. Write a compound inequality that represents who is not eligible to play. So you can see this little kid wouldn't be able to play, and this old guy wouldn't be able to play. So let's go ahead and create the compound inequality. So now we have x, and we're going to be comparing it to the number 14. So it says if you are under 14, so numbers that are under 14 would be like 7, 10, 2. Those are people who are under 14, so that would have to be less than. All right. People who are older than 18, so when you're comparing x to the number 18, someone who's older than 18 would be like 19, 20, 31, and those people would be above. So this would be greater than 18. Now over here there's an or, so we're going to go ahead and put the or in there, and then we're going to go ahead and graph this. So we have 14 and 18 again. This time we have open circles because we do not have or equal to bars. Again, this is asking who cannot play, and we already determined that 14-year-olds and 18-year-olds can play. So we got open circles there. Now for this one, x is less than 14, that's going to go up to the left. X is greater than 18, that's going to go up to the right. All right, or means that at least one shading. So there is at least one shading over here. There is at least one shading over here. So we're going to count that as our solution. We are not counting 14 and 18 because those are those are open circles. All right, so this is what the graph looks like. All right, what are some solutions? Now, these are solutions. The question again is who cannot play. So someone who is 1 can't play, someone who's 4, someone who's 6, someone who's 13. These are people who can't play because they're younger than 14. Also, people that are older than 18 can't play. So 19, 25, 88. These are people who are not able to play in the tournament. And I don't know why someone who's 88 would want to play in the tournament anyway. He'd probably break his back. All right, so go ahead and try number 10 on your own. Number 10, it says, to ride the bus for free, you must be under 7 or a senior citizen, 65 and above. Write a compound inequality that would represent the situation and graph it. Go ahead and do that right now. All right, so again, we have people taking the bus. These people want to go on for free. The people who are able to go on for free are little kids and old people, all right, because you have to be under 7 or a senior citizen to be able to go on for free. So under 7, what we would write for that is x, when we're comparing it to 7, all right, so someone who's under 7 would be like 6 or 2 or something like that. So 3 and 6 are good examples of people who are under 7, right? So that's going to be less than. Now, it doesn't say that 7-year-olds are free, so that's why there's no or equal to bar. Now, the other part of this is senior citizen. Senior citizen is 65 and above. So when we put x compared to 65, we do want the or equal to bar, all right, because it says 65 and above. These are some ages of people who are above. So 75 is greater than 65, okay? You see the or here, so we're going to put the or in there. Therefore, we're going to say that 7 and 65 are on the graph. This one's an open circle. This one is a closed circle. All right, then we're going to go ahead and graph this one. These numbers would go that way. These numbers would go that way. And then again, or means at least 1. So there's at least 1 over here. There's at least 1 over here. And then there is at least 1 over here, which is the blue. So we are going to include 65. Okay, so that's what the graph looks like. Here are some solutions. We have 1, 4, 6. Now these are people who are under 7. They'll be free. And then we also have the 65-year-olds and anybody above 65. So these people would also go on the bus for free. Okay? All right, guys, I'll see you tomorrow. And good thing I just made it again with that red light.